Excellent. So it's been a couple weeks since I have joined you guys. I know that the recordings didn't necessarily work last time. Is that right, Dom?
Yeah, so YouTube no longer supports Hangout, and then we discovered this the day of. So it's Zoom or nothing from now on.
Fair enough. Was there anything that came up that is worth sort of doing a quick recap on?
It was mostly Sug giving his his progress, if I recall. Do you remember, Suggy, what we talked about? Suggy's quiet.
He's muted.
Oh, it was 2 weeks ago, so I'm not. What we were talking. No, I think there was. No, I think there was nothing really particularly important. I guess. I think we just like talked about the bug fixes and stuff. Yeah.
Cool. Okay. Well, then maybe we can move on and do a quick update from anyone who has updates.
Joe, you're gonna do the whole meeting standing and walking? That'll be great.
No, not yet.
Excellent. Well, Dom, do you want to start us off with reports you defended?
Yeah, that's it. I defended.
Excellent. Well,
oh yeah, that was crazy. So we tried to broadcast. Sorry, Sag. I had to be abrupt and kill it, but it's weird. My computer was connected to the HDMI, and then even though I shut off my volume on my computer, I could still hear Zoom, the app, like my feedback, my own feedback. So it was super annoying.
Oh, strange.
Yeah, I'm not sure. Yeah, I don't know. Could be a Windows bug, but so we don't have a recording because of that.
Yeah. How did it go? Did you get some good questions?
Oh yeah, hard question.
But he answered them admirably, so there was no problem.
Excellent.
Exactly. But what came out of this is that we have a new pull request. Anyway, we can go with more details later, but I have a pull request up. I'll put it on in the notes.
Sounds good. Perfect. Anyone else at UBC with updates?
Yeah, I started to play around with getting my tutorials updated for the simulation class. I think I mentioned that in past weeks. So I've got some forward modeling for the FEM and TEM, which seem pretty fine, but I ran into some issues with DCIP. So either there is a bug or there's something that I'm not doing correctly. So I'm looking into that, and I've started doing the same thing for the potential field stuff now that Dom is merging in his changes. So yeah, there's some energy being put towards that, but it's an ongoing process.
Excellent.
Devin did the first derivative on the gravity gradients. So I finished it. Now we have gravity gradients that are coming up.
So the derivation was correct. That's the important thing.
For the first component, yeah, and then I just basically finished the rest after. So
Excellent.
thank you, Devin.
Devin, are there any questions or blockers? Like, are there things you would like to go over with somebody, or do you have an example that you want to post on Slack with respect to DCIP, or is that something you just want to plug away at for a bit?
I have to get it into shape so that somebody could actually look at the problem, not be confused at what I'm doing.
Okay, fair enough.
If there is a bug, it has something to do with the amount of keyword arguments being entered into something and not matching the thing that it's talking to. So I think I need to learn what the latest keyword arguments are for, I think it's the simulation class.
Are you on simulation the JK?
No, just simulation for now. So another thing is, yeah, simulation is got TEM and FEM stuff on it. John is working on the natural source stuff. So if I wanted to develop anything for natural source codes, I'll work on that. So just be sort of nice to know which branches we're working on which simulation types, because maybe the stuff is done and I'm just working on the wrong branch. I'm kind of switching around for each.
Well, it sounds like there's a message from John on Slack that his work is like basically a pull request ready.
Okay.
So we can bring that into the simulation branch so that you can just keep plugging away off of simulation. I think like for the development of tutorials and stuff like that, staying on simulation is probably the most sensible trajectory right now.
Yeah, I like that idea as well. And so any issues that I have, I'll sort of point to what is missing or what roadblock I run into working on simulation class or simulation branch. I like that. So.
That sounds good. Thanks for pushing on that, Devin. That's exciting.
No problem.
Simulation JK would be the most best for these.
Yeah, but she's gonna pull. Yeah, so she's gonna pull that in, and that's probably big. I met with John last week, and we talked about it. So he's probably looked at it already. Yeah, it was done for sure.
Cool. All right. Anyone else at UBC with updates?
I've been playing a lot with TreeMesh and the MVI code from DOM lately, so there are a couple of pull requests that are like small things that are coming in soon for that. Like, so there is a spherical map, so that will be a mapping specifically for the MVI code. So instead of doing things under the hood in the Mac code, you create a spherical map to go from Cartesian to spherical and reverse. So that simplifies a lot the code.
Cool.
There was a function that exists for TreeMesh, for TensorMesh that did not exist for TreeMesh. So I added it in. It was not necessary, but maybe just maybe add it for symmetry or ask even if it's required for TensorMesh. And I should push soon to the shading option for the plot2D utils.
Excellent. I'm just going to tag you in the Google Doc, if you don't mind, either during or after the meeting, maybe just dropping links to the pull requests in there, and then we can take a look at those. Cool. Anybody else at UBC?
Nope.
Nope. Okay. Sagi.
Yeah, I have two things. So I'm not sure you guys are familiar with the iconal solver. Somehow I knit it here. So I found one package that does the forward modeling. So I was using it not for a travel time tomography, but like a little bit different questions. But it seems pretty nice and fast. So yeah, potentially we can put that into a simple problem class. That was one thing.
Oh, which package?
It's called SKFMM. It's using fast marching method. So yeah, I could post you guys. Yeah, it's I think there are a couple of bugs, I guess, but it's nicely written. I think it's using C code, I guess. But anyway, so if anyone is interested in travel time tomography, there's a code. And I started like a mesh decomposition for airborne EM. So I was asking Joe like if he has a volumetric interpolation codes, and I checked a couple of interpolation in SciPy. So if the grid is actually regular, so it's like if the grid size is same, not like, but the dx, dy, dz could be different. But if all the cell size of all the cells are same, there's a really fast interpolation in SciPy. So that seems a good solution for me, at least at the moment, to interpolate from 3D grid to a local grid. So I think I'm getting pretty close. So that serial code is sort of done. So I'm moving into the parallelization of this 4 problem. So yeah, I'll keep you guys posted about that. Yeah, I think that's on my end.
Excellent. Joe, do you have any updates?
Yeah, sure. I opened up a volume averaging branch on Discretize to try to play, so you guys can kind of play around with the volume averaging function just before I do any sort of pull requests. I want to make sure it's working properly first, and I'd like you guys to test it out if you can. Right now, it's just working for tensor meshes, like from one tensor mesh to the other. I know how I can do it for tree meshes quickly. The idea is I just go to the underlying tensor mesh and then compare the two tensor meshes of underlying tree meshes, and then it would work. Otherwise, there'd be way too much logic. But other than that, I'm starting to work on the poster for the SEG for Misak's memorial session afterwards. So I would appreciate any help on that. Should be up on a collaboration page. But
Do you
that's
have
about all I got.
a Google Doc or like a slide started for that? Or how do you want to, what's your preferred mode of working on that?
I mean, I'd be fine with a slide on Google Slides, just so people want to edit it or add things and change things around. So I'd be happy for any help.
Sounds good. Well, if you want to, I'll just add you here, and whenever you have a chance, if you can maybe just drop the link in the notes, and then we can jump into.
Sure thing.
Thanks. Cool. Okay, I can give a bit of an update. So I was at the Pangeo meeting 2 weeks ago. So that was held at UW in Seattle. And I gave a talk there, so spoke a bit about SimPEG. And so there's some people who were quite interested, and I wouldn't be surprised to see 1 or 2 more people jumping in somewhere down the line because of that, hopefully. But also it was extremely productive just for connecting with people who are in the Pangeo community. I had a great chat with Matt Rockland, who does Dask, and sort of just getting some of my mental models sorted out. And Dom and I worked together on just getting a better understanding of what's actually going on with solvers when you use Dask. And so it's dangerous to parallelize or to like simultaneously have Dask wrapping basically a PyMat solver, Paradiso solver. But other than that, like I think there's a lot that we can leverage within SimPEG to parallelize using Dask. And I've been using Dask and Dask job queue quite a bit. And maybe at some point I can actually give a quick demo on that, maybe next week or the following week, on how that lets you actually like deploy. So what I've been doing is being able to send basically expensive computations from a notebook that I'm running on an interactive node at NERSC to HPC nodes. So I basically set up my entire simulation, and then I have a little function that basically runs that simulation, but I want to run that on one of the bigger nodes. And so you can use Dask job queue to do that, which is pretty slick. So yeah, I can maybe next week or so we can give an example of that. The other really big and very exciting piece that came out of this is I had a good chance to chat and sit down with some of the Conda Forge folks. Now basically the entire SimPEG stack is up on Conda Forge, which is awesome. So that should really drastically simplify installing Discretize in particular on Windows machines, because now there's a recipe for it. What this means is, so what we ended up doing is getting the entire SimPEG stack on there. So everything from PyMat Solver, PyMKL, GeoAnna, Discretize, SimPEG, I think that's most of them, all up on Conda Forge. And so anytime that we make a new release of any one of those packages, basically a little Conda Forge bot will go and update the recipe. And right now I'm listed as the maintainer of those. So I just need to go and check that, the version number is correct. If there's anybody else who's willing to be listed as a maintainer, all that means is like you just go and check that the Conda4j bot did things correctly. And if there were any updates and requirements, we have to edit that manually. It should be fairly light load, but it would be nice knowing that I'm not the only one watching those things. So if there's anyone who's willing to jump in there, that'd be awesome. Yeah, I think that's my biggest updates from those meetings. The other thing, and we can chat about this either in the meeting or offline afterwards, is sharing notebooks and things like that. I know, Dom, you were pinging, and I don't know if you and Doug were successful or not on getting an environment set up, but it might be worth just chatting through what an effective sort of community strategy for all of us when sharing work, what that actually looks like. Because I think, yeah, when we're all sort of working on our own different branches and things like that, it can actually be a little non-trivial to send someone a notebook and have them up and running right away. So I don't know if that's a topic we want to dive into.
It's certainly an important topic, whether we actually treat it here or somehow offline, and then try to figure out what needs to be done. I think this is where it's tremendously valuable that I'm here, because I'm probably the worst case scenario. If you can get it working for me, everybody else will be okay.
Well, and I think, I mean, if
You're the piece, would be the worst case scenario. You're actually not the worst case scenario. Sorry.
Yeah, okay, so I think the couple things that we had maybe for longer items, and feel free to chime in here, is because we could pick this up, and I think it's actually probably worth discussing as a group, is because if we do actually come up with a standard way of sharing notebooks amongst each other, I think that would streamline life for most of us. And then, Dom, you were mentioning potentially details on the pull request, if you want to do that now, or if that is like an offline after the fact.
No, let's keep it for later. It's going to be boring for most people.
Okay. Oh, the one other thing I wanted to ask is there's the pull request from Jay, Jaja's student. I was wondering if somebody would be willing to shepherd that. I was thinking either Dom or Thibaut, because I think you both are most closely connected with the work that he's done. I don't know if either of you have bandwidth to do that.
Well, I started leaving notes. I didn't do like a forward, but I left notes in it, and there's a lot of work to be done. I mean,
Okay.
It's not ready to come now, as is.
Okay, fair enough.
And I don't think you replied to any of those comments, so it's kind of in the air now.
Okay. I wonder if we should reach out and just send him a quick email. Maybe Dom, you and we can coordinate on that, because he might not actually be watching GitHub notifications all that closely. I don't know how familiar he is with GitHub.
Right.
Okay. Yeah, we can coordinate on that afterwards. Okay, so let's maybe chat through then sharing notebooks. And I'm wondering, maybe Dom and Doug, if you could give just like a quick overview of what you were trying to do, because I think that this pattern is probably pretty common.
Well, I can tell you what we're trying to do. So we had a notebook that was just investigating a topic that we've talked about for a long time, and that has to do with, as you're solving the inverse problem, you want to, set up the objective function and keep, make sure that the evaluation of that objective function is mesh independent. And, there's been a lot of discussion within the group about that, and Dom had what he called a simple difference technique, which definitely speeded up all of the computations. But I think the whole aspect of going back and revisiting that issue is important. So I asked Dom to put together, a simplified notebook that I could take a look at. So he slacked it to me, and then it was a question of okay, how do I actually get it onto my computer and get it working? So, we put it made a special directory, Dom's notebooks, and then, I attempted to run it, and then it did not run. And I have a lot of things on my computer that were out of date, discretized, SimPEG. I mean, there was just quite a few things that were out of date, but it wasn't clear, like, to start with, exactly what's out of date and what needs to be done. And then, from there, Dom, with your help, Lindsay, we're, kind of providing some ideas about, okay, what needs to be, what does need to be updated, how do you update it, and the whole process is non-trivial, and if it can be somehow captured so that anybody else could have a set of checks and balances, like, okay, I have to make sure I do this and this and this, and then I should be good to go. I think that would be really, really valuable.
Yeah. So one question for Dom in this case, so the environment that you were expecting Doug's computer to be running on, was that basically off of master on everything, or was it off of specific branches of stuff?
No, man. Yeah, I did it all based on master. So his discretize was behind, and his SimPEG was behind. And there was the thing about Xcode on Mac that we needed to install, he didn't have, so that's why the Git pull didn't work. So it's kind of a combination of hardware installs and Python installs.
Okay. And were you successful in getting it up and running, or is there still some hardware stuff?
No, we're good now. They're just that Mac OS Xcode something. I'll try to find the link and add it in case people add it. But other than that, it's just we need to check the dependencies for updates, right?
Yeah. So there's like sort of two thoughts I had on this. I mean, if you're running based on master, then sort of telling somebody to update their SimPEG environment and discretize to be running off of the latest master is probably fine within this group. But I'm wondering if for more like research oriented stuff where you're probably working on your own branch of something, if we want to try and get into the habit of actually just always sharing like at the repository level. So in the sense, like always sharing basically a notebook plus an environment file. Because then what you can do, first of all, is everyone familiar with environments? When I say environment file, I know some folks in the room are very familiar, others are roughly so.
I am, yeah.
Okay, so just like a quick overview for those who are maybe less familiar. So with all the stuff that we run up on Binder, for example, we've always had to specify like an environment.yaml file. And what that does is it tells you what packages that you need in that environment to be able to actually like run the software. And so repo to Docker, which is sort of one of the core pieces of the Binder project, what it does is it looks at that file, it builds you the environment, and then Binder plops you into that environment with the notebook open. So Binder is like one workflow of showing that a notebook is reproducible. You can actually run the same process basically on your own computer, where you create that conda environment. It's just conda create and then -f, which means file, environment.yaml. And then you activate that environment, and then you run the notebook, and then you can deactivate the environment. So it's a few steps, but what's nice about that is then like you can, as the notebook author, you are responsible for specifying whatever branches of stuff somebody's supposed to be on. They can create that environment that has all of that, and then you don't actually mess with their base software environment. And then if somebody else was more familiar and actually wanted to change their base software environment, they could just look at the branch structure from the environment file.
So is this a separate file and that's going to go with the notebook?
Yeah. Yeah, so you'd always have to share both of those things.
And then the next level is just to share the notebooks through my binder, but that takes some setup.
Well, actually, it doesn't take really any more setup at that point. Once you specified the environment and the notebook, that's actually all a binder needs. It just needs to be then sitting on GitHub.
So I have then an environment file, and I've got a Jupyter notebook. And then do I just use like a command window to activate the environment and then write Jupyter notebook, and then I'm good to go? Is that?
Yeah, yeah. I mean, that wouldn't necessarily have solved some of the issues that you ran into this morning because Xcode was acting, but in the future that like hopefully streamlines some things and makes it easier for somebody to give you like a research notebook that does have a weird dependency tree.
And then if I ran the environment file, does it come back and tell me that certain things are incompatible, they're out of date, or I haven't updated? How does that work?
So it actually, it doesn't mess with your base environment at all. So it's not going to tell you that anything in your base environment. So when I say your base environment, I mean like what you have access to when you run Jupyter Notebook from a command window right now. What happens when you create an environment is it basically says, okay, I have a sandbox here. I'm going to fill it with the software that you've told me to fill it with. But I'm actually going to go look at the source, which is GitHub or PyPI, whatever. I'm going to go look at the source, grab the software, and stick it in that environment, like stick it in that sandbox. And then I'm going to put you in the sandbox with your notebook, and you can run it from there. That's what activating the environment does.
So if you thought about the idea of having like old versions of things, so you've got something that's continually updated, but your particular notebook is really running like an old version of something, then this would counteract that. So then GitHub would just figure out, oh, you don't want version 1.7, you actually want 1.6.
I mean, so whoever authored the notebook would need to put that information in the environment file. But yes, once you've done that, then Conda will create the correct sandbox for you based on that file.
Okay.
So, I mean, we have most of this in place in like the SimPEG research repositories, but it's just a question of like, do we want to try and make it a habit from like the outset rather than when we're packaging it up for distribution.
Sounds good.
Okay, well, we can give it a try and see. I think some of the research repos in the like the SimPEG research actually have pretty good instructions as to like how to use Conda environments. So we can play around with it and see if that works for folks.
Is it easy to make the environment file, or are there templates even for such?
Yeah, it's pretty straightforward. I can actually show you. Let me just pull up one. Okay, so
Tells you which channel and it's on Pip or Conda.
Yeah, and at the top, the name of your map.
We can see your screen, yes.
Excellent. Okay, so this is just one of the SimPEG research repos. And so here, there's the environment.yaml file. So this is the name of the environment. So it's pretty simple structure. So the name of the environment. So what you would do is you git clone this repository. Actually, I think the instructions are even in the README. Yeah, so you git clone the repository. You go into it, you create the environment, and then you activate that environment. And then you can launch the notebook. And then afterwards, you can Conda deactivate. But when we say conda env create this thing, so what this means is like you're going to create an environment and you want it to create it from a file called environment.yaml. And so that file gives the environment a name, so that's the AEM environment, tells you which channels to use. So now we can use Conda Forge actually to install all the SimPEG stack, which is great, because that streamlines things a bit. And then we specify the dependencies. So these ones are all Conda or Conda Forge dependencies. And then these ones are pip or PyPI dependencies. You can also specify, if you want to install a specific branch of something, you can specify that actually via pip. It just is like git plus the URL and then at a branch name. So that's all it is.
And add git as a requirement for that.
Actually, you don't need to. It comes with git by default.
I'm not sure about that, but anyway.
Okay, you should specify pip as a dependency, but the git should work straight away.
So I got a question then. When we did GPG labs and we made that available on my binders, you can still hear me, right?
Yeah.
Okay. Did we give the address to the GitHub repository, and then my binders looked for a file called environments.yaml and built that, or did you specify the particular YAML file and then built and sort of deployed it? Like, did you have to specify it, or did it look automatically?
It looks automatically. So it's standard practice to name your environment.yaml.
.yaml and put it in the directory.
Yeah.
Okay, yeah. I just wanted to know that for my own.
Yeah.
Cool.
All right. Any other things that people wanted to chat about or things you want to make sure that we go over next week?
I have some thoughts about Jupyter notebooks for the Myanmar training.
Mm-hmm.
That's more appropriate to talk about it just amongst us or whatever.
Go for it.
Okay. So I guess there's more directed towards talking Lindsay, but yeah, it took a while, but yeah, I hammered out a plan which for the training, and it's kind of an alternating structure now. So for the most part, there's like a half a day of stuff in the field and a half day back in the office, and then 2 groups of 25 people each, so 50 in total. And if that allows more people to actually use the instrument, because if you have 50 people out in the field, it's going to be logistically challenging to say the least. Yeah, and then so I probably won't go over like exactly how that's configured, but then I came up with a set of about 6 or 7 notebooks that I think would go along with that curriculum. And I guess I was curious about your thoughts on that and everyone else, of course. So the first one would be just a 1D4 modeling. And Lindsay already has a notebook that pretty much does this, but perhaps we can modify it. One thing I noticed there is, I think the existing one, it has, I'd like a few additional arrays. Oh, sorry, I was thinking for 2D. Okay, I'll look at that. Anyways, yeah, second notebook would be a 1D parametric inversion, and this is all for DC resistivity, by the way. So I was wondering if we have something like that already existing, actually.
I think there is. Look at there's a notebook sprint. I'll point you, Kevin, because that was our initial example in the original SimPEG paper. So I think we used the Schlumberger array.
Okay.
I think we used the 3D code to do it, but like in this case, we could use the 2D code to do it, I think.
Okay. Great, I'll follow up with you then after that. And then the third notebook, also I think we can draw upon existing materials. basically just a 1D linear version. I mean, Thibault gave a great tutorial, and please don't assume that. Or I see some other versions floating around there, but it's something along that, and maybe with some commenting. And then the fourth one, I guess I don't know what you call it, a non-parametric or like smoother version for DC, also in 1D. And yeah, perhaps your notebook, Lindsay, the one you sent me called Untitled, that would be okay. Yeah, I mean, it's, could change the name, less artsy perhaps.
Kevin, what is the 1D what is the difference between 1D parametric inversion and 1D? What was the difference?
Well, so then it would just be a smoothly varying model as opposed to particular layers.
Okay, so are you thinking about like basically having, you'd specify 3 layers and we'd invert for the layer thicknesses and resistivities for the parametric, like something like that?
Yes.
Okay.
Oh, I think that we don't have, I guess.
We have a lot of the bones of it though.
Yes, absolutely. But yeah, we need to put it together.
Yeah.
Okay. Okay, and then this one, a 2D4 modeling. So kind of having a pattern, increasing the dimensionality, right? Yeah. So then for this one, I think we could definitely use some of the materials from 350, like the lab. I think there's already a pseudo section visualizer. Perhaps having some additional arrays though. Like I don't remember when there's Schlumberger being there. And there's also this array called either reverse or reciprocal Wenner Schlumberger. Something that Max mentioned that they use at Boulder a lot. He thought it might be useful to include. And I don't believe those are already there. And then maybe some kind of some animation to show how you build up the pseudo section. I think I've seen one of those before used in 350, but like for each of those types of arrays, I don't know how much time that would involve, but it would definitely be useful.
Mike, I think, Mike, you created the pseudo section widget that's in one of the DC apps, right?
It's a good question. I might have. I think Don built something at 1.2. So I might have been building. I think you might be right.
Because there is a pseudo section little widget that you can play with. It's in one of the DC notebooks. But take a look at that, and I'm sure between Dom and Mike, you should be able to find it and see if that satisfies what you're looking for. And if you have something else in mind, then we can extend that. But if it works out of the box, then that's great.
Okay. And I'm not sure if it would also be useful in that same 2D4 modeling notebook to have some tool to visualize the sensitivity.
I think it does have, right? The 2D4 modeling app does have a function to plot the sensitivity, I guess. Well, there may be quite a few different 2D notebooks, but I think the one that we use for the disk, I think it does have.
That does it? Okay.
Like the 4 electrodes one, I guess.
I think it's there's one called Layer Cylinder. That one for sure, I think, has like almost all the functionality that we have. And that one, I'm pretty sure you can view the sensitivities. The other ones, I think it's in most of them, but it's entirely possible that the notebook that you looked at did not have that.
Okay, I see.
I remember working with Thibault and getting those sensitivities in to most of those DC ones, like either the plate or the cylinder. But I think the plate and the cylinder, we both have them in it.
As long as none of you break anything involving GPG Labs. Just don't.
Well, Devin, one thing that you can do, and this probably is not a bad idea. I mean, so this work should be happening in GeoSci Labs, not in GPG Labs.
Yeah.
So GeoSci Labs, we can freeze at this point and just not accept pull requests for the whole semester.
Yeah, if you did that, that would be fantastic. I mean, I think what we've done now is we've sort of at everything at whatever the current state is, and put that on the computer so that it's not going to be updated or sort of messed if dependencies change. But yeah, as little thought as I have to put in as possible to maintaining GPG Lab would be great.
And Devin, if there are things that change, we'll loop you in, and like you'll be involved in any pull requests that happen. I can make sure that happens. I mean, I don't imagine that there's going to be lots of changes, but if there's a small fix here or there, like absolutely, you'll be kept in the loop on that.
Yeah. I just want to throw it out there because yes, I'm going to be using it this semester, and I have sort of dealt with everything during the summer, and I don't want to have to think about it.
Fair enough. Okay, so a 2D forward modeling.
Yes, to continue, almost there. In the notebook 6 would be 2D version, logically, or I guess 2.5D seems to be what's being used mostly. And yeah, this should be the real workhorse notebook. That like a lot of the other ones are kind of more for demonstration purposes, but it's my hope that this is one that, you know, whenever they do ERT, this is the one they'll come to. So yeah, it should be pretty functional. And I think, yeah, a lot of the tutorial notebooks on SimPEG could probably be used for that purpose with a bit of tweaking and commenting and stuff like that. Yeah, and then the final one is a bonus. I may be stretching, but I was thinking of more maybe like advanced topics on a notebook for 2D TC, in which people could play with, you know, putting in prior geologic structure, regularization, and also topography, or any other advanced topics. But those are the two big ones that I thought about. And I'm not sure what kind of form that would look like actually, so we could discuss that if you have any thoughts.
Kevin, there's like a couple of resources that we have used in Argentina. Well, not quite, but I mean, we built like a 2D inversion, like an app, for instance. So you can take a look and have you look at the Crosswell, like a tomography app where we do a 2D inversion?
No, not that one.
Yeah, I think it'll be pretty helpful for you to take a look and have a feel for it, what could be possible, and we can go a step further, like from there. It got different application, but I think it has most of the ingredients, I guess. So yeah, take a look. I think it's in the GPG Labs. I'm pretty sure.
Should be in
GPG Labs. Like it was initially in the GPG apps, which does not exist anymore. Well, not sure. Like because we merged everything into one place.
I'll just put a note in the notes, Soggy. I think it should be in GeoSci Labs.
Right. Oh, GeoSci Labs. That's what I meant. Not GeoSci Labs. Right.
Yeah, and if you wouldn't mind maybe just adding like the specific name of the notebook, just so Ren can find it afterwards.
Yeah, I'll point to Kevin.
All right, thanks.
Okay, yeah, that's my thoughts.
Excellent. What's the most effective way for like us to collaborate with you on this? Like, what are there things that you need from us right now, or is it right now just sort of chatting through ideas?
So I think honestly, you know, maybe a few months ago it would have been more my preference to try to build these things myself, but it seems we're running out of time, unfortunately. So if you have the bandwidth, I would really appreciate if you folks could put these together. I could do commenting and stuff like that. I think I have a decent enough understanding that, you know, I can look through whatever code you make and then simplify it in comments for people. But if you could put together the actual materials, that'd be great help. And then I can focus on building the slides, which is still in progress, but getting there.
But do you have a sort of a sketch about what the functionality would be in each of these?
Yes.
Yeah.
I mean, it's very preliminary.
Okay.
Yes. Yeah. I can pass around that document. But in terms of timeline, yeah, probably by the end of this month. Yeah, I don't know how that works with your guys' timelines.
Okay, well, let's maybe chat about this offline afterwards, if that's all right with you guys.
Sure.
Cool. Okay. I don't have too many other things other than Dom. I'll just briefly, we can ping back and forth on Slack and maybe just like draft a quick email to Jay. Yeah, and I think that's it, at least on my end for action items. Anything else? And I guess connect. So Sagi, Doug, Bren, and I can connect via email or Slack just to come up with a bit of a game plan for notebooks.
Okay.
Cool.
So Lindsay, are you planning to show us like the desk job queue stuff next week? Is that our plan?
Sure, let's plan for that. I'm in Seattle next week, but there shouldn't be a problem for me to be able to join the meeting. So I can definitely prep some stuff to show you all for Dask job queue. That'd be fun.
Sounds great.
And Saga, where are you working for the parallelization of EM?
Yeah. So I am. I did some. I used the Joplib at the moment, but I still want to use the Dask, but I think like my experience so far wasn't great. I just had a hard time to optimize just very simple, embarrassingly parallel problem. So yeah, I want to learn a little bit more from you guys.
Yeah, but if you look at John's branch for the DC, it should be really straightforward to do the same for EM.
Okay, I'll take a look. So what he parallelized the sensitivity?
That's right.
Okay, I'll take a look. Yeah, it's a little bit different parallelization that I wanted to do, but I mean, there should be some analogy, I guess.
Well, I mean, if you discover something better, that's fine. But it would be great if all the simulations kind of use the same architecture, because there's no reason that they should be different, right?
Right. Yeah, I'll take a look. Is that the simulation, JK? Is that where he's working on?
Yeah, look at the resistivity simulation, and then you'll be able to figure it out.
Okay, sounds good. I'll take a look.
I have another pair of eyes on it.
Yeah, that'd be great.
Sounds good.
Any last burning items from anyone?
Nope.
Well, congrats again, Dom. Big defense done. That's awesome.
Thank you.
Good to see you all. So we'll see you all again next week.
Bye-bye.
Bye, guys.
Happy hands.